Hello class, our new topic is influence lines for beams. By definition, an influence line is a diagram showing the variation of certain functions such as reaction, shear, moment, stress, or any other direct function due to a load of unit value moving along a structure. The ordinate to the influence line at any point is the value of a certain function due to a unit load acting at that point. So let's go straight to solve problems. Example 8.1. For the cantilever beam shown, draw the influence lines for shear at C, shear at B, moment at C, and moment at D. So V stands for shear, while M stands for moment. Yung subscript C, yan yung point sa gitna. Okay, ayan from the figure. Tapos A, yan yung free end, B, yan yung support. And then the distance between AC is 2 and then C to B is 3. So, letter A, find the influence line for shear at C. So, ang technique dito, mag-cut ka ng section dun sa point, and then dun ka mag-cut, pero maglo-load ka ngayon ng unit load dun sa free end, in this case sa point A. Take note na magkakaroon ka ng maximum moment dun sa pag naglagay ka ng load sa dulo. Okay, so that would be 1 times the length na 5, which is this. Yan ang maximum moment. And the problem says, draw the influence line for shear at C. Okay, using unit load at the free end at A. Okay, since yung lecture natin sa shear and moment diagram, kapag shear, tapos concentrated load, remember na horizontal line ang kanyang drawing, okay? Tapos, nag-cut tayo ng section sa C, which is at distance 2 meters. Ibig sabihin, dun sa C, parang yan na yung support niya. Okay, diyan tayo nag-cut. So, ang plot ng ating influence line would be negative 1. Dahil, yung direction niya is pababa, So, negative. And then, plot niya is horizontal. And then, mag-i-stop siya sa point C. Then, balik siya sa 0. Okay, next is plot the influence line for shear at point B. It so happen na yung point B nandun sa support. Kaya, ang plot mo is horizontal line, dire-diretso siya dito sa point B. And then, sa moment naman, plot the influence line for moment at point C. So, nag-cut tayo ng section dito sa point C. Assuming mo na dun sa cut section, dun yung support. Okay, for concentrated load, yung plot ng moment would be first degree. So, straight line na incline. And magte-terminate siya dito sa point C. And then influence line for moment at section B would be at support. Okay, so yung inclined line mo, dire-diretso yan hanggang sa support. Next, for problem 8.2, we have here a cantilever beam. And draw the influence lines for reaction at A. Take note na kapag reaction, parang shear din yan. And then shear at C. And then moment at point C. And then moment at point A. And then yung moment at A, this is simply the same as moment reaction at A. Determine the maximum values of these functions for 1, a moving concentrated load of 4 kilonewton, and 2, a uniformly distributed moving load of 500 Newton meter. Notice na this time, meron na tayong concentrated load tsaka 500 na distributed load. And meron tayong point C with a defined distance from the support. Okay? So, similar to problem 8.2, draw the influence line for reaction at A. Ang reaction naman, take note, ay directed upwards. Tapos, kapag influence line, you always put a unit load at the point where it will cause a maximum shear and maximum moment for a cantilever beam. In this case, dun sa dulo, which is the free end, point B. Okay, so uniform horizontal line lang yan, which is this. And then B, influence line for point C. So magkakat tayo dito and then assume that this is the support. So yung figure mo, magte-terminate siya sa C. And then influence line at C again, dito ang mag-cut ng support. And then, yan ang diagonal line mo. So negative 5, that is simply your unit load times the distance na 5 meters. Dito naman, influence line for moment at support or moment at A, you have negative 8. Now, considering the concentrated load of 4 kilonewton. This time, considering a concentrated load of 4 kilonewton, again, applied at the point where it will cause a maximum shear and moment, it is at point B. So, letter A, that would be reaction at A, that is 4 kilonewton. Notice na yung mga may parenthesis, yan yung mga influence load values. Dito sa letter A, that is 1. Ito siya, no? Sa letter B, 1 ulit. Tapos sa letter C, negative 5, which is this. And then sa letter D, you have negative 8. And then, considering your 4, yung unit load na 1, palitan mo yan ng 4. Okay? So, simply said, shear at A or reaction at A would be 4 times 4 times 1, no? Or it will give you 4 kilonewton. And then at B, 4 times 1 again would give you 4 kilonewton. And then at letter C, 4 times negative 5 will give you negative 20. And then at D, 4 times negative 8 would give you negative 32. Likewise, dito sa letter D, 4 times 8, yung simple moment equation would give you 32. Okay? Next, let us consider the moving load of 500 Newton meter. Kapag sinabing uniformly distributed, okay, meron tong value per meter. Ibig sabihin sa kada metro, meron siyang 500 newtons. Dito naman, again, notice na yung 1, 1, negative 5, tsaka negative 8, yan din yung mga values due to the influence lines. Okay? Which is, ito, this is 1, tapos 1, negative 5, tsaka negative 8. Okay, ayan. 1, 1, negative 5, negative 8. And then, yung 500, yan yung uniform load. So, nag-cut tayo ng section dito sa support. So, pupunuin mo yung entire length ng 500 Newton per meter. Okay, so, simply said, 500 times length times your influence line. That will give you 4,000. And then, at C naman, nag-cut tayo ng section dito. So, 500 times length times the influence line na 1 ulit. Okay? So, it will give you 2,500. Sa moment at C naman, that would be, take note, nag-cut tayo again ng section dito sa C. So, ang length mo would be 5 meters. 500 times 5. Okay? Ito yon, 500 times 5. And then, times 1/2 nung length. Okay? So, kaya meron dong 1/2. And that will give you negative 6,250. Notice na yung 500 na yan, parang pinalitan lang natin yung unit load. Ano? Tapos next, moment at A naman. So, pinuno natin yung entire 8 meter length ng 500. So, 500 times 8 multiplied by the lever arm na 1/2 nung 8. And that will give you negative 1,600 or negative 16,000 Newton meter. For 8.3, for the simply supported beam, draw the influence lines for reaction at A or shear at A, reaction or shear at B, and then shear at C. And then finally, moment at C. And determine the maximum values of these functions for 1, a moving concentrated load of 10 kN and a uniformly distributed moving load of 3 kN meter. Okay. So, dito naman, meron tayong C at distance 4 meters and 8 meters at the other end. So, for reaction at A, para ma-maximize mo yung reaction at A, okay, maglalagay ka ng unit load sa ibabaw niya mismo. Okay? And reaction at A becomes now positive 1. Reaction is always upwards. Ganon din naman sa point B. For reaction B to be maximum, doon ka maglagay ng unit load sa taas niya mismo. Kaya meron ditong positive 1. Okay? Ngayon, kung maglalagay ka ng unit load sa gitna niya mismo, then shear at A would be 0.5, shear at B would be 0.5. Hindi na yon maximum. And then, shear at C. Paano yan? Shear at C would be the combination of these two reactions, okay? So, mapapansin nyo, ito yung triangle, tapos, ito naman yung triangle due to B. Since they are both unit loads, derived from unit loads, ang idea nito ngayon, naglagay tayo ng unit load dito sa ibabaw ng C. Okay? Sa ibabaw ng C mismo. Kaya, if you will notice na pag i-add mo yung 2/3 tsaka yung 1/3, that would give you a length of 1. Okay? So, that's the idea. And then, ang unit load naman at section C, ang moment at C, ito. Okay? So, notice na yung moment diagram niya is concentrated load, Ayan. And, paano nakuha yung 4 na triangle na yan? Okay? So, yung 4 na yan, that pertains to the distance. Ito. Okay, next, yung 8 naman, yung value na 8 na yan, yung height ng triangle, also pertains to this distance. Ngayon, kunin mo yung height ng intersection dito sa point C. That would give you 8 over 3. Okay? So, masasolve mo yan by ratio and proportion. Now, let's apply the concentrated load of 10. So, at point A, or reaction A, maglagay ka niyan ng 10 dyan, obviously, magiging 10 din na reaction A mo. Ganon din sa B. Now, maglagay tayo ng 10 kilonewton sa shear at C. So, yung shear at C, okay, you simply multiply that by 2/3. So, 10 times 2/3 will give you 6.77. And that is shear at C positive, okay? And 10 times negative 1/3 would give you negative 3.33. Okay? So, that is 10. Kung i-add mo yung 3.33 plus 6.67, yung kanilang absolute values magiging 10. Okay, and then finally, D. For letter D, your moment at section C would be 10 times this value, 8 all over 3 will give you 26.67. This time, gagamit tayo ng 3 kilonewton per meter na uniform load. So, reaction at A would simply mean 3 times the entire length, okay? Pero hahatiin mo yon. So, 3 times 12 times 1/2 would give you 18. Ganon din sa B. 3 times 12 times 1/2. It will give you 18. And then for letter C, okay, for shear at point C, that is the area, no? So, yung area na yan, that would be 1/2 times 2/3 yung height, tapos yung length na 8. Yung area ng upper triangle, okay? Ito, 1/2 times 2/3 times 8, i-multiply mo nung 3 kilonewton meter. So that is your positive shear at C. And then yung negative shear naman, ito, again, that is the area of this triangle multiplied by the load na 3 kilonewton meter. So, yung area nitong lower triangle, that would be 1/2 times, ayun, times negative 1/3 times the length na 4 meters multiplied by the uniform load na 3, which will give you negative 2. And finally, dito naman sa moment at C, again, it is the area of the triangle. So, 1/2 times 8/3 multiplied by the length, which is 12 meters, multiplied by the uniform load na 3, which will give you 48 kilonewton meter. Hello class, so our next topic is criteria for maxima for beams, moving loads. So, meron tayong maximum values for simple beams due to uniform live loads. Live loads in the sense na ito yung mga wheel loads, yung mga sasakyan. Kapag dead load naman, yun yung self-weight, that is the beams, tapos yung slabs, and then yung mga railings, kung bridge ang pinag-usapan. Okay, for case 1, we have a uniform load of sufficient length to cover the entire beam. So, eto, the entire length is covered with uniform load. So, ang maximum reactions niyan is on both sides, WL all over 2, or that is 1/2 W times L. And then we have case 2, uniform load which is shorter than the span. Okay, so pwedeng A is greater than L over 2 or A is lesser than L over 2. In which case, A is always lesser than the length. Ayun, para ma-maximize mo dito yung shear, ilalagay mo yung isang end ng uniform load sa support. Okay, so reaction here becomes WA all over L times the quantity L minus A all over 2. Now, you can derive this using summation moments at B. Now, let's go to the next page. Dito naman, yung uniform load, nilipat niya sa reaction B. In this case, ang maximum reaction mo dito ay nasa point B. Okay, so same equation lang sila. This is 2L minus A. This is also 2L minus A. Next, we go to maximum shear. For this problem naman, ang sosolvin natin is yung maximum shear within the span and not at the supports. Okay? So the maximum shear at a given point in a simple beam occurs when the load extends from the point to the farthest support. Okay, so ito ang ating point, yung letter C. Dapat aabot siya sa either support A or B. In this case, yung span na naloadan is B, which is greater than A. So the maximum shear occurs at point C, which is equal to WB square all over 2L. Tapos, ito yung kanyang influence line. No? Notice that this vertical line above the horizon is B all over L. Kapag i-add mo yung absolute values ng vertical line above tsaka yung vertical line below the horizon, that would give you a value of 1, which is equal to the influence line for shear at point C. Okay, pag sinabing influence line, laging unity ang ating pinag-uusapan dito. And then we have letter B. The absolute maximum shear in a simple beam occurs at the supports when the beam is fully loaded. Ito siya. And then letter C. Maximum moment at a given point. Okay, so ito yung ating point. This time, yung load natin ay hindi umaabot sa support. And then we have letter C, maximum moment at a given point. So for case 1, uniform load shorter than the span. But this time, yung ating uniform load ay hindi umabot on either supports, which is defined by the length C, okay? Which also happens to be on top of capital C. Ito, okay? And then, meron tayong dimensions na X tsaka C minus X. Being X is the smaller dimension. Okay? The maximum moment at a given point occurs when the uniform load is placed such that the point divides both the load and the span in the same ratio. Okay, in the same ratio. In the sense na yung A over B is equal also to X all over C minus X, which happens to be this one. Alright? Another thing is, kung sa length ng uniform load, ito ang smaller, dapat sa length ng beam, A din ang smaller. Okay? Para makapag-produce ka ng maximum moment. And then we have here case 2, uniform load of sufficient length to cover the entire beam. So the entire beam natakpan pero meron kang point C. Okay, so fully load the beam to produce the maximum moment at a given point in a simple beam. So ito yung kanyang equation. At point C, the maximum moment is W times L over 2 times AB all over L times L, which happens to be 1/2 times the WAB. Okay, and then letter B, absolute maximum moment in a simple beam occurs at the midpoint when the beam is fully loaded, which happens to be 1/8 times WL squared. Okay? So, alam na natin itong equation na yan. WL squared all over 8. That is the moment for a simply supported beam. Next, we have here maximum values for simple beams due to a single concentrated live load. So, applicable to sa isang gulong. To maximize the value of either reaction, place the single concentrated live load over the reaction, which is at A or B, and then for maximum shear at a given point. So dito, ang ating given point is yung letter C. The maximum shear at a given point in a simple beam due to a single concentrated live load occurs when the load is placed an infinitesimal distance to the left or to the right of the point and on the longer of the two segments into which the point divides the beam. So, maximum shear at point C is simply equal to P times B all over L, which is also equal to R1. The absolute maximum shear in a simple beam due to a single concentrated live load occurs when that load is placed at infinitesimal distance from either support. Okay, so in this drawing, ito yung kanyang influence line. It is 1 for reaction 1, and therefore your maximum shear is also equal to R1, which is equal to the concentrated load P. Sa maximum moment at a given point, the maximum bending at a given point in a simple beam due to a single concentrated live load occurs when the load is placed at the points. Again, at point C, the maximum moment is PAB all over L. Next, absolute maximum moment in a simple beam due to a single concentrated live load occurs when the load is placed at the midpoint of the beams. Kapag sinabing maximum, absolute, okay, iisa lang ang location niyan palagi. Yeah, and obviously that is at the midspan of the simple beam. Okay? That is applicable for concentrated single point load. Likewise, that is also applicable for uniform load over the entire length. And then we have two concentrated unequal loads. Ito, dalawang gulong na hindi magkaparehas ang bigat. So, para ma-maximize yung reaction or yung shear, ilagay mo yung isang load sa support. Obviously, your P is the larger among the two concentrated loads, okay? And then you have the distance A that is between the two loads. And your reaction here is P plus Q times L minus A all over L. And then the maximum shear at a given point in a simple beam due to two unequal concentrated live loads occurs when both loads are on the longer segment with the greater load at an infinitesimal distance from the point. Okay, so ito yung kanyang equation. R1 is equal to 1 all over L times PB plus Q times B minus C. Also, remember of these assumptions. Your P should be greater than Q and that B should be greater than A. Okay? And then the maximum moment at a given point in a simple beam due to unequal concentrated live loads occurs when the larger load is placed at the point with the smaller load on the longer segment. Yan. So yung Q, that is the smaller load, dito siya nakalagay sa longer segment. Tapos yung longer, yung mas mabigat na weight, nandun siya sa point in consideration, which is C. Okay? Then you have this equation. Absolute maximum moment in a simple beam due to two unequal concentrated live loads occurs under the larger load when this load and the resultant of the two loads are equidistant from the midpoint of the beam or from the ends. Ito ang ating magiging problem. Okay? So, kukunin mo na dito ngayon yung resultant ng dalawang loads, which is this one. Okay? Take note na P is greater than Q. Tapos meron tayong reaction dito. Reaction is simply equal to, or this is resultant. Okay? That is resultant equal to P plus Q. Tapos meron tayong center line dito. Ano? Yung center line na yan, that is equal to L all over 2. Okay, tapos meron tayong eccentricity. Ngayon, yung eccentricity na yan, that is the distance from the resultant to point P. Para ma-maximize mo yung moment ngayon, ilalagay mo yung gitna between P and R, ilalagay mo yung gitna niyan coinciding with the center of your beam, which is E over 2 and then E over 2. Okay? So, in short, yung centroidal mass, nilagay mo pa rin sa gitna ng beam. Parang naging concentrated load na siya, pero nasa gitna na. The above criterion is to be applied when both loads are on the span. Ibig sabihin yan, yung parehong gulong nasa loob ng beam. For the above criterion is to be applied when both loads are on the span. However, in certain cases, it may happen that the two loads are far apart and applying that criterion will cause the smaller load to lie outside the span. In this case, placing only the larger load on the span will give the maximum moment. Kapag nangyari yun, lumabas na yung isang gulong, magiging point load na lang siya, isang gulong. To determine which condition will govern, apply the formula. L prime is equal to C times the quantity, 1 plus the square root of P all over R, where L prime is limiting value of the span such that the two loads on the span will produce the maximum moment. Ibig sabihin yan, yung dalawang gulong nasa loob pa rin ng span. C is the distance between the loads, P the heavier load, and then the resultant P plus Q. If L is greater than L prime, okay, ito na yung mga conditions na i-compare natin dito sa L prime. If L is greater than L prime, two loads on the span govern. If L is less than L prime, the heavier load at the center of the beam gives greater moment. If L is equal to L prime, either one or two loads govern. And then we have the maximum reaction. For that to happen, ilagay mo yung load P sa isang reaction. Okay? Then we have the maximum reaction here, which is P all over L times the quantity 2L minus A. And then for maximum shear at a given point in a simple beam due to two equal concentrated live loads. Yan. Ibig sabihin, this is the same. No? Parehas silang P. Obviously, ang resultant niyan is 2P at ang kanilang location ng resultant is C over 2. Absolute maximum shear in a simple beam due to two equal concentrated live loads is equal to the maximum reaction. And then maximum at a given point in a simple beam due to two equal concentrated live loads occurs when one of the loads is placed at the point with the other load on the longer segment, which is like this. In this case, maximum is R1 times A. And lastly, the absolute maximum moment in a simple beam due to two equal concentrated live loads occurs under one of the two loads when this load and the resultant of the loads are equidistant from the midpoint of the beam. Okay, so to determine the limiting value of the span, which will indicate whether one or two loads govern, we find from equation 10.18 by substituting P is equal to 2P, and we have these equations. Maintindihan natin to with examples, which leads us to the next lecture. By the way, ililimit natin ang ating mga samples sa uniform loads tsaka dalawang wheel loads lang. So for example, 10.1. Reviewin natin si equation 10.6, which is this one, okay? Yan yung ating previous lecture. Notice na proportional ang kanilang loading. Ayan, no? Meron tayong distance A, that is the smaller distance, and B is the greater distance. So remember na yung ratio and proportion. Dapat parehas sila. Okay? In beam AB, figure 10.31, C is a fixed point. The problem is to determine the position of the uniform load of length C, wherein C is lesser than L, such that the moment at C is maximum. Okay, so hahanapan mo ngayon ng value yung X in terms of L, A, or B. So, summation moment at B is equal to 0. The reaction 1 is equal to this quantity. So, eto, summation moment at B is equal to 0. Take note na yung R1 times L. Ito yun, no? Yan yung R1, tapos yan yung L. Ang kinokontra nitong R1 is obviously this vertical downward uniform loads, which is ito, no? So, W times C times X, yung load na yan, ito. Yan yung longer loads na nagkahati dito sa uniform load over the small length na C. Okay? At ang lever arm nito would be length B minus CX all over 2. Okay? Ulitin ko. The lever arm is B minus C minus X all over 2, which is this. Next is yung equivalent concentrated load would be from this distance X. And that is W times X times the lever arm na B, okay, plus X all over 2, okay? Ang lever arm nitong maliit na load niyan is B plus X all over 2. And then from there, you can get the equation for R1. So, the maximum moment or moment at C would be R1 times A, okay, minus WX squared all over 2. Nangyari yan kasi nag-cut tayo ng section dito sa point C, yung loads lang dito sa left ang i-consider niya. Okay, so R1 times A minus WX times X all over 2, which is equal to this. So that is your moment at C. Differentiating this expression and equating the derivative to 0, we obtain x is equal to AC all over L. And then we will skip 10.2 and 10.3. You read that by yourself and analyze. For problem 10.4, so meron tayong point C sa loob ng 18-meter beam, and then we have a 9-meter long na uniform load of 5 kilonewton per meter. So, we will look for comparison to this. So, ito yun. So, article 10.2b. Ito siya, no? So, this is 10.2. This is letter A, maximum reaction. Letter B, this is maximum shear. Okay, so this is letter B. The maximum shear at a given point in a simple beam occurs when the load extends from the point to the farthest point. So, ibig sabihin yan, isang edge nung 9-meter na beam, ipapatong mo dito sa point in consideration. Tapos, syempre, dito mo i-extend sa towards B. Okay? Dahil this is 9 meter, obviously, pag ilalagay mo siya dito sa 6 meter shorter length, lumampas na. So, dito mo siya ilalagay sa 12 meter na span. So, your reaction now is 1 all over 18 times the quantity 5 times 9 times the quantity 12 minus 4.5. Ang comparison niya dito is this one, okay? Ito naman ngayon para makuha mo yung ratio. Yan, x all over c minus x is equal to a all over b. Okay, so ito na yung kanyang R1 and then you have the maximum moment. Determine, for example, 10.5, determine the maximum combined shears at 2-meter intervals in a 20-meter long simple beam supporting a dead load of 4 kilonewton per meter and a uniform live load of 10 kilonewton meter. In this example ngayon, take note na ang ating letter C, yan yung point in consideration, ano? So, ang letter C mo magkakaroon ng several values. One at 2 meters, 4, 6, 8, and then we have 10. Yan ang values. So, you have several solutions. Okay? So, ito ang kanyang dead load shear applied over the entire span. Then, we have the live load shears, which is 10 kilonewton per meter. Now, let's go to two-wheel loads, which is example 10.6. Two loads, each 6 kilonewton and spaced 10 meters apart. So, equal loads yan, ano? Move on a simply supported beam. Compare the values of the maximum bending moment in the beam due to two loads on the span and due to one load only at center if the beam is A 16 meters, B 17.07, and C 20 meters. So, ang i-compare natin ngayon dito sa equation na yan ay ito. Ayan, no? So, that is section 10.5. Maximum values for simple beams due to two equal concentrated live loads. Alright? And then for tama na yan. You try solving on your own, guys. See you later on the next topic.